Right, I'm Eugene, and you may know me from all these other big things that you may see in all those other videos, but now I'm stuck in another dimension. And more notably, all I have to work with is this writing utensil, because I've encountered this construct problem in this proving grounds that asks to five the smallest power of 5 that is greater than 2 to the power of 30. So all I have to work with are my ordinary powers. So let's see. I know right from the start that I can do a bound. 5 squared is 25. 2 to the power of 5 is 32. 25 is less than 32, so I can raise both to the power of 6, maintain the inequality, and yet 5 to the power of 12 is less than 2 to the power of 30. Here's the problem. All the answer choices have exponents larger than 12. So what's the next best thing? Okay, I did some more experimenting and found that 2 to the power of 9 is 512. 5 to the power of 4 is 625. And so 512 is less than 625. And so I can raise it to the third power to get 2 to the 27 is less than 5 to the power of 12. And I also know that 2 to the power of 3 is 8, and 5 to the power of 2 is 25. So that's another inequality. And so 2 to the power of 30 is less than 5 to the power of 14. So at the very least, I know that the 15, 16, 17 can't be the smallest exponent, so I can eliminate that right off the bat. So now I'm stuck between 5 to the power of 14 and 5 to the power of 13. Where does that land? So I tried a lot of experimenting, including trying to raise it to higher powers and seeing if there's work. One idea that I tried was multiplying both sides by 2 to the power of 13 to make a comparison between 10 to the power of 13 and 2 to the power of 43, except the numbers got big way too fast, and it's going to be way hard to explain things. I think I start to see why. So as I raise things to higher and higher powers, the gaps between numbers would just get bigger and bigger and bigger. That's how exponents work. So if I want to get a good estimate that accurately and precisely puts 5 to the power of 13 to its place, I need to find the powers that would be raised small enough so the gap wouldn't be too large, as well as bounds and comparisons that are really close but decisive enough such that when I do raise it to the powers, it will be a lot easier to discern. So what do I have? So I know that 125 and 128 are really close. So I can say that 5 to the power of 3 is less than 2 to the power of 7, which is 128. And more notably, I can say 5 to the power of 12 is less than 2 to the power of 28. Bad news is that 5 is greater than 2 squared, which is 4. So, but there is another thing I can try. So fortunately, multiplying and dividing things would maintain the inequality. So I can attempt another maneuver, which is 5 to the power of 12 times 5, and then see how that compares with 2 to the power of 28 times 2 to the power of 2. And then if I keep on dividing both sides, I can do a comparison with 0.8 and 125 over 128 to the power of 4. So if I am able to get an approximation for what 125 divided by 128 is, and then see how that compares, I might be able to pinpoint more exactly. So now to find 125 divided by 128 and see where that lands. So if I attempt to work this out, because I know if 95 squared is 9,025, somewhere around that, but large enough because 9 squared is 81. So if I can show that 125 over 128 is greater than 0.95, then that should be good enough. So what do I get? So I think it's a lot easier to check out 3 over 128. Maybe because of the division. Or maybe I can just do some simple long division because at least I can know that the leading digit is going to be a 9 right from the spot. So I can do some long division. 9 times 8 is 72. 9 times 2 is 18, 25, 11, 52. Subtract, bring down. So 49. And then, okay, 128 times 5 is, that's definitely more than 0.95. So at least I only have to do long division twice. And now that I know 125 over 128 is greater than 0.95, and then 0.95 square that would be a bit more than 0.9, and 0.9 square that would be greater than 0.81. And that is close enough. So fortunately, the actual bound, it's not 9 at 5. So I can say that with good confidence that 125 over 128 to the power of 4 is greater than 0.8. And that makes all the difference to say that 5 to the power of 13 is the smallest power of 5 greater than 2 to the power of 30. All right, finally made my way out of my proving grounds. Now I'm trying to see where to go next. Looks like I still solved the problem and got a value. Going all big turned out to be disadvantageous here, but keeping things simpler actually worked out for this problem. Maybe good enough?
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.